All right. So the pyramids that we're going to talk about are ones that are right pyramids, which is what it looks like that, right? This is called an oblique pyramid where it's like slanted. All the ones we're going to do are going to be right pyramids. So a pyramid, here's the definition. A pyramid is a polyhedron. Now remember, polyhedron means it's 3D and it's made up of all polygons. Okay, a pyramid is a polyhedron, special kind of polyhedron, where you have one base, but the base will be a polygon, some kind of polygon, and the lateral faces, they're not rectangles this time. What are the lateral faces going to be? Triangles, right? See how they're coming up to a point at the top. So the lateral faces are still what you think of as lateral faces with pyramids. It's just that this time, instead of going straight up, they're going to be coming into a point up at the top. So the lateral faces, there's one base, and then the other ones are the lateral faces. The lateral faces are triangles. With a common vertex. Okay, where two lateral faces come together is called a lateral edge. And then where a base and a lateral face come together is called a base edge. If you see that down there, that's a base edge because it's a side of one of the bases. And then the perpendicular distance between the base and the vertex of the pyramid, what would that represent? If I dropped a perpendicular here, what would that represent? So what is that of the pyramid? It's the height, yeah, it's the height. So we're going to kind of approach these the same way as we did the other ones. We're going to go through and find, you know, perimeter of the base, height, base area, all that stuff. It's just the formulas will be different because now the faces are, the lateral faces are triangles. That changes the formula a little bit. Okay. Regular just means that the pyramid has a polygon that's a regular base. So if the base is a square, or if the base is a regular triangle, or if the base is a regular hexagon, okay, that's called a regular pyramid. Now, what's different? So you can see on this picture, they've got the height shown there. What's different on a pyramid is this thing that's called slant height. Slant height is if you were up here at the vertex at the top of the pyramid and you slid down one of the faces perpendicular to the base. That's called slant height. Okay, so it's not going along one of the edges, it's actually going down one of the triangular faces. The slant height of a regular pyramid is the altitude of any triangular face. We use the letter L for slant height. I know that's kind of like Y. Well, S sometimes looks like a 5. So we try to avoid using S as a variable, but they've chosen L. I don't really know why, but when you see L, and it's going to be a cursive L, don't make it look like a 1. Okay, that's going to be a slant height. So let me grab a pyramid here. The height and the slant height are different. All the slant height will be the same as you go around the shape. Okay, so this is a pyramid. This is a pyramid that has a triangular base. Here's a triangular pyramid. Here's a triangular pyramid. And then here's a cone. Okay, so when you're looking at a pyramid, this right here is the slant height. That's the slant height. So it's just a height of one of the triangles. It's not the height of the prism. Yes. It's not the height of the prism because the height of the prism would go from here to where? Straight down, you put the midpoint right there. center of the skull. The height of the person is in between my fingers. This is the slant height. So all those slant heights would be the same, because if this is regular, all of these triangles. That's slant height. This is a triangular pyramid. Pyramids don't have to have square bases. You need to think about in history. Different pyramids, but a pyramid can be just a regular octagonal pyramid. They just have to all come up to points because they're triangles. Here's a pony. Okay, so slant height is going to be used for some of our calculations here. Here's the formulas. Same thing that we did yesterday or Tuesday, except that we have this extra dimension there. Okay, so we still have capital B is base area, capital P is perimeter, little h is height, and then L, cursive L is your slant height. Now, lateral area, the lateral faces are all triangles now. Okay, so when you do lateral area, you're going to be adding up the sum of the areas of its lateral faces, which are triangles. Always triangles. Now, because they're triangles, we're going to be using 1/2 base height of the triangles. Okay, so 1/2, the perimeter of the base is going to take all of the triangles at one time. And multiply by the height of the triangles. Now, is the height of each of those triangles going to be the height of the pyramid or the slant height? The slant height. Okay, if you look at one of these triangles, it's going to be the slant height right here will represent, that's, you know, that segment right there. That's going to be the height of the triangle. So that's the height of the triangle. So our formula for lateral area for a pyramid will be perimeter of the base multiplied by the height of the triangle, not the height of the pyramid. Okay, so it's going to be 1/2. The letter we use for perimeter of the base is capital P, and the height of the triangle is actually the slant height. Okay, the slant height represents the height of the triangular faces. That's what slant height is representing. Okay, so lateral area, lateral area, 1/2 perimeter times slant height. Now for surface area, we're going to take the lateral area and add on what? How many bases? Just one. Okay, I'm going to write 1 in the front there just for emphasis. You don't have to have a 1 there. Okay, but there's 1 base, not 2 bases, 1 base because it's a pyramid. Now for volume, for a pyramid, we're going to do the same thing we did with volume for a prism, except that because it comes into a point, it's got a smaller volume. And it's actually a third. I know if you were guessing, you think it was a half. It actually takes 3 of those pyramids to fill up a prism with the same base. So the volume of a pyramid is 1/3 base area multiplied by the height of the pyramid. So volume is 1/3 area of the base multiplied by the height. That's your formula for volume for a pyramid. Okay, and here's your surface area formula. Oops. Now, again, I'm going to give you those formulas just like you're getting the formulas of the prisms and the cylinders that are written on the board. It'll be the same thing with the pyramids and cones. Okay, find the lateral area and the surface area of this regular square pyramid. Now, regular means the base is equiangular, equilateral. It's a square, so I didn't really have to say regular. If I had just said a square pyramid, that would imply it's regular because squares are regular, right? Hey, Ryan, what are you doing? Okay, the base of that is what? A square. Okay, slant height. So we have the slant height, we got to find it. We have it. What is it? 30. Diamond. Yeah. The base on a pyramid is going to be more obvious. So it doesn't have to sit on the bottom, but there's only one of them, and then all the other ones will be triangles. So even if I turn it sideways, the base is still the square. But it'll be more obvious with the pyramid than it was with the prism. Are they always going to be what? Not necessarily, but for example, if I wanted you to find the slant height, so let's say I didn't tell you that it was 30, would you know how long that segment is? It'd be 10. And then if I gave you the length of, this is called the lateral edge, if I gave you that length, let's say I told you that was like 25 or something, how would you find the slant height? That's on a 360-90. Pythagorean theorem, okay? So they might not give you the slant height, but they should give you enough to be able to figure out the slant height if it's not given. Well, but you weren't given that. You can't just assume. It has to be told to you. Or if you knew it was a right triangle and you knew that, if you knew it was a right triangle and I told you that's like 4 and this is 4√3, that's going to force it to be a right 30/60/90 because of the relationship of the 4 and the 4√3. Or if you knew that this was 4 and that was 8, that would force it to be a 30/60/90. But for what we're doing, you know, I kind of have to tell you 30/60/90s or tell you the triangle is regular. Remember when we start with a regular triangle, when you drop in an altitude, when you drop in the altitude, that'll create a 30/60/90 because this was already 60. But generally, you kind of have to be told or you have to know they're regular triangles or regular hexagons. Okay, Peter, perimeter of the base. What is it? Okay, 20 on a side, 4 sides, 80 millimeters. This is a pretty tiny little thing. Okay, area of the base. Gabe, what kind of base is that? So if this side, if you have a square and this side is 20, what's its area? 400. Yeah, so remember that's a regular, it's a square, so it's just side squared. 20 times 20. It'd be millimeters what? Squared. It's not surface area or lateral area, it's perimeter. You're just determining how far, if you were to walk around that square, it's how far you would walk. Okay, that doesn't have anything to do with the triangles up here. It's just asking you for the perimeter of the base. Now we're going to do surface area and lateral area. Okay. Now, lateral area, remember we talked about the formula up here. Lateral area is 1/2 perimeter of the base multiplied by the slant height. I'm using green, I don't remember. 1/2 perimeter of the base multiplied by the slant height. Now, we already have the perimeter of the base, we already have the slant height. And again, the reason there's a 1/2 here is because they're triangles. They're not rectangles this time, they're triangles. So it's 1/2 base times height of the triangles. That's why there's a 1/2 there, because they're triangles instead of rectangles. So it'll be 1/2. Perimeter of the base is 80. Slant height is 30. Okay, Jake, what's that going to be? So this is 40. What'd you say there? Oh, okay. So your final answer is 1200. And then what's the label? The volume gets more complicated because what do you have to know for volume? You need the base area and you need the height of the prism, of the pyramid. Do we have the base area? Do we have the height? So I made my honors kids draw on a right triangle. You can find it. You can either use, it's called the apothem and the height and the slant height, or you can use the height and over to the corner there if you need to. But to find the height, you have to draw a triangle standing up inside, and it just gets a little bit more complicated. So I'm not making you do volume on this one. So depending on what you're given, you might have to do everything. You might only have to do part of it. Okay, and then for surface area, Braden, we're going to take the lateral area and do what? Not divide it. Do what? Plus one base. Okay, so our lateral area was 1200. Our base area was what? 400. So that means our total surface area for the pyramid will be 1600 millimeters squared. Okay, so again, I will give you the formulas that you need. I'll give you these, but you have to know what capital P means. You have to know what the cursive L means. Because if I give you the formulas and you don't know what those things are, then it's not going to be, very helpful. Okay, find the lateral area and the surface area of the regular pyramid. Okay, so the base is a regular what? Hexagon. Now this one's going to be more difficult because our base is not a nice simple square, right? Our base is a regular hexagon. Actually, I should say regular there. Let me say regular hexagon. Oh, it does say regular. Sorry. I don't have to say regular then. Sounds good. Okay. Do we know the slant height? Yes. It's what? 18. What's our label? Inches. Okay. Perimeter of the base. Kendall, what's the perimeter of the base? Tell me how you get that. How many sides are there? 48. 6 on a side. Oops, sorry. 6 sides. The other way. 8 on a side, 6 sides, 48 inches. Okay, now for the area is going to be a little bit more complicated, right? This is what we did when we took our hexagon and we divided it into all those congruent triangles. I'm going to go ahead and draw in. So sometimes when you're looking at the 3D shape that's on, a 2D paper, it's kind of hard to tell what's happening. So we're going to do an aerial view here. This is our base if we were looking down on it. Okay, so I want to think about this one of these little triangles. So we want to figure out that triangle area, and then we'll do what with that answer? By 6, multiply by 6. Okay, how do we start? Okay, we know that this is going to be 4. Let me make that skinnier. We know that this is going to be 4 and that's going to be 4. What else do we know? Okay, so remember that these are regular triangles. All of these are 60 degrees. These central angles are 60. Right, so that means when you draw in the altitude there, it's going to cut that into a 30 degree, 60 degree, 90 degree triangle. In a hexagon, they're always 30, 60, 90s. Okay, so do you remember how to get the long leg from the short leg? 4 radical 3. Okay, so that length is going to be 4 root 3 inches. So our right triangle, if you need to kind of see it this way, this is our 30, 60, 90. We've got 4 here. That'd be 4 root 3 there. So that's a short leg to the long leg. Okay, that's called the apothem. It doesn't really matter if you know that term, but that's called the apothem of the hexagon. Okay, base area. Area of one of the triangles. Let's switch colors here. Area of one of the triangles is 1/2 times what times what? 8 times 4 root 3. That's the green triangle. Okay, this is the green triangle. Blair, what do you get when you multiply that? Huh? What do you get when you multiply that? Okay, 16 root 3, and that's going to be in inches squared. Okay, is that our answer? No, got to do what? Multiply by 6. So you might want to, at the beginning when you're first doing the problem, you might want to kind of make yourself a note to not forget to do the multiplication. I don't know how many problems I checked on the honors test where kids did this and then they forgot to multiply. So like they did the hard part and then just forgot to multiply in the end there. Okay, so this will be multiplied by 6. That'll give you your total base area is 216. No, 96 root 3 inches squared. Okay, so don't do all the hard work and then forget that you've got to multiply to find the whole entire hexagon. And this is the hexagon area. Okay, so again, we found the area of one green triangle, and then there's 1, 2, 3, 4, 5, 6 of those. So we multiplied by 6 to get the entire base area. Okay, formula for lateral area. Lateral area is 1/2 PL. So 1/2, the perimeter of the base we found was 48. The slant height we were given in the problem was 18. I don't know what that is. 24 times 18, 432, I agree. 432, what's the label gonna be? Inches squared. Okay, Sarah, how do you get the surface area from the lateral area? So the lateral area is all of these triangles areas added up. What are you missing when you do the lateral area? The what? I'm looking for a face, right? Surface area is if you're going to paint the entire surface. So lateral area is just if you painted the triangles all the way around. What are you missing if you only paint the triangles? The base. And again, this is a pyramid, so there's only one base. Surface area is lateral area plus a base. So 432 plus what? 96 root 3. Now, can you put those together? No. What's the label? Inches squared. Okay, so again, everything builds on everything else. So if you make a mistake someplace, we'd be able to go back and figure out where the mistake happened so that we can, like, you know, go forward and check what you did based on that. So if you misidentified, like you calculated the perimeter wrong, like Kendall said 64, she just made a mistake and said 64. If you have 64 here, oops, sorry. If you have 64 here, then that means that it would throw off this because that uses perimeter. It would also throw off that. But if this is wrong, but these are okay based on that mistake, then I don't take off very much, okay? It's not like if you make a mistake here and then you get everything wrong. I follow your mistake through and see if your calculations are right based on that. Okay, a cone. You know how a prism and a cylinder were kind of the same idea, except you had circles in the cylinder? A pyramid and a cone are kind of the same, except that you have a circle base instead of a polygon. Okay, but a cone's like a cylinder, except it only has one base. So here's our cone. One circular base. And there's not triangles this time, because again, it's like, you know how if you buy a ice cream cone and a sugar cone, how they put that paper around it, right? That's what it's like. Or like on a drumstick, you know, frozen drumstick where the paper actually goes all the way up to the top. It's not just wrapped partially around it, like covers the whole part. That's what our lateral area is going to be. Is going to be that paper if you unrolled it. Okay. Terminology for a cone. The watt of a cone is the perpendicular distance between the center of the base and its vertex. The height. Okay, that's the height. So exactly what you would think, same idea as a pyramid, perpendicular from the base up to the vertex. Let's call the vertex up at the top there. Okay. The radius, just like with a cylinder, the radius of a cone is just the radius of a circle. And then again, like a pyramid, a cone is going to have a slant height. So the slant height will be, if you do a visual, you know, look at it from the side here, that's going to be your slant height. So either of those is your slant height. They've got it drawn over here, but both of those are slant height. Okay, so again, the slant height will not be the same as the height because the height will be perpendicular from the vertex perpendicular to the base. That's your height. Okay, height and slant height are different. But slant height for a cone is the same idea as slant height for a pyramid. Okay, now the difference with a cone is that instead of having to find the base area of some polygon, the base area will always be what in a cone? Pi r squared, because they're circles, right? Where base area is always going to be pi r squared, and our perimeter of the base will always be pi d or 2 pi r, okay? They probably give you a radius more often than diameter, but either one is fine, okay? So basically, we're just kind of doing the same thing, except that wherever we see capital B, we'll do pi r squared, and wherever we see capital P, we'll be using 2 pi r. I don't even care about these formulas, like deriving these formulas. I'm just going to write for you here. Lateral area is 1/2 the perimeter of the base multiplied by the slant height. So really just the same formula. Okay, and then surface area, you're going to add on a circle. So it's still going to be the lateral area plus 1 base. It's 1/2 perimeter times slant height plus 1 base. We're going to treat this just like a pyramid, except that you'll be plugging in the pi r squared and the 2 pi r. And then volume for a cone will be 1/3 area of the base times the height. Okay, we're just going to use the same formulas. We'll just calculate using circles now. Okay. What is the radius? 6. Okay, so in that picture, our radius is 6. Lily, do we have the slant height or do we have the height of the pyramid, of the cone? Lily, is that slant height or is that height of the cone? That's slant height. So our slant height, again, is if you look at it from the side, if you were sitting up here at the vertex of the cone and you slid down, Okay, or like you're holding your cone in the other way around and the ice cream starts dripping down. It's gonna follow, you know, this way. That's your slant height, so that's 10. Okay, now our height is not shown on the picture. Let me go ahead and draw in a segment that would be your height. So again, your height needs to be how tall it is. So perpendicular to the base from the vertex. This is our height. Derbla, how would you find the height? Okay, so what's the equation? Equals what? 10 squared. Did you say 20 or did I just mishear you? Okay, I probably just misheard you. Okay, I'm using h to represent height. So we've got 36 and 100. So that'll be 64. So h is what? 8. So this is one where Duran asked me about, like, do we not have to do volume on that one pyramid? This is an example of where, you know, they'll give you the slant height, the radius, you got to find the height. Or maybe they give you the height and the slant height, you need to find the radius. So that right triangle there, the Pythagorean theorem, is super useful on any of these where you have to find the height or the slant height because they're right triangles. Okay, so our height is 8 feet. Austin, base area, what will we do? Good. 36 pi feet squared. And we're always going to leave these exact unless I tell you, which means with pi, unless I tell you specifically otherwise. You should be leaving the answers exact. And that way there's no rounding. Everybody gets the same exact answer. There's no, oh, I multiplied by 3.14 and I multiplied by pi, or I rounded differently than you. Okay, it's always going to be the same. Okay, why did they not ask you to find the perimeter? Well, I could have put perimeter in there. I didn't, but we're just going to go ahead and like do it all one time. Okay. The formula for lateral area is what, Diamond? What's the formula for lateral area? Okay. So instead of finding the perimeter separately, we're just going to go ahead and do it right now. So 1/2, the perimeter would be what? 2 pi times 6. And then what's our slant height? 10. Now, I want to see these calculations. Like, I want you to write down what you're doing. I don't want to just see an answer, because if you try to do it in your head, you're likely to make a mistake. I need to see what things you're multiplying. Okay. The 1/2 and the 2 just cancel each other. All right. So that'll give you 60 pi feet squared. Okay. Surface area. Izzy, what do we do to get the total surface area then? Okay. So I'm just going to use lateral area plus a base because we already have the lateral area up above. You don't really have to redo that calculation, right? So our lateral area we found was 60 pi. And what's our base area? Okay, so what's your final answer? What's the label? Okay, and again, make sure you're practicing putting the labels on your answers, because then on the quiz or the final, you will automatically do that because you've been doing it all along. Okay, how about Ryan? Volume of the cone, what's the formula? Just a side note, you can also write this as the base area times the height divided by 3. So depending on the numbers, if it works better to divide by 3 than it does to mess with the 1/3, they're the same thing, okay? All right, so base area. What are we using for base area? 1/3, 36 pi we found up above. Our height is 8. And again, make sure you use height and not slant height. So here, height, we're using here. Okay, slant height, we're using here. Putting in the 10 there, okay? So pay attention to, my green looks kind of like my blue. Let me change that. I don't know if that's any better. That's better, nope. That's better. Okay, so final answer here. 1/3 of 36 is 12. So we're doing 12 pi times 8, which will give you, 96 what? Feet cubed. Okay, sometimes I get students saying, wait a minute, how did the surface area and the volume end up the same? Are those the same answers? Why not? One is square and one is cubed, okay? This one means little tiny squares that you're filling up the surface with. This one means little tiny cubes that you're filling up the inside with. So it's the same number of things, but they're different things. Okay, so it doesn't matter, the numbers are the same. They're not always going to be the same. It just happened with the numbers we had here. It happened to work out to be the same. Okay, why don't you try this one? We'll see how it goes. If you want to do your perimeter separately, like Diamond asked, why didn't I have a perimeter slot? If you want to do your perimeter separately, that's fine.